Let's discuss question 9.36. At a county fair, a boy takes his teddy bear on a giant Ferris wheel. Unfortunately, at the top of the ride, he accidentally drops his stuffed buddy. The wheel has a diameter of 12 meter. The bottom of the wheel is 2 meter above the ground, and its rim is moving at a speed of 1 meter per second. How far from the base of the Ferris wheel will the teddy bear land? Let's sketch the problem. You have a Ferris wheel, and the diameter of that Ferris wheel is 12 meter. The Ferris wheel is at a height 2 meter above the ground. So from the ground, the base of the Ferris wheel is 2 meter above. Therefore, if you measure the height of the top of the Ferris wheel from the ground, it is 14 meter. The question says the rim of the Ferris wheel has a velocity of 1 meter per second. So V here is 1 meter per second. And this is the tangential velocity of the Ferris wheel. That means this is only the x component of velocity. The question says a boy took a teddy bear in the Ferris wheel and drops the teddy bear from the top. So when the teddy bear is released, it will be released with a velocity of 1 meter per second initially, and then it will fall under the influence of gravity like this, following a parabolic path. We need to find how far from the base of the Ferris wheel does the teddy bear drop. So we need to find this distance, which we call as range, or the distance along the x-axis, which we will take as x. In order to find the distance of the teddy bear from the base of the Ferris wheel, we have to apply the principles of projectile motion. In projectile motion, the object is accelerating only along y-axis. So we have acceleration along y-axis, which we can write as ay, which is equal to acceleration due to gravity g. But along x-axis, there is no acceleration. So we can write ax as 0. If there is no acceleration along x-axis, I can find any distance along x-axis by just multiplying the x component of initial velocity with the time t. And why the initial velocity? Since there is no acceleration along x-axis, the x component of velocity remains the same. So Vx at the top here will be the same Vx at the bottom, and I just need to multiply this Vx with time t to find what is x. Question has given me the velocity along x-axis, which is 1 meter per second. I need to find what is the time t. So we are going to use the equations along y-axis to find time t. I have been given the displacement along y-axis, from what height the teddy bear is falling. The diameter of the Ferris wheel is 12 meter and it is 2 meter above the ground. So the teddy bear is falling a total height of 14 meter. So I can write the height h to be equal to 14 meter. This height h will be the displacement of teddy bear along the y-axis, which we can write as delta y. And when I write delta y, I will take this value as negative since the teddy bear is falling down. When we are discussing vectors, anything that is going down, we generally take that to be negative. And since the teddy bear is falling from a height h, we will take delta y to be negative 14.0 meter. Acceleration along y-axis is acceleration due to gravity g, which is negative 9.81 meter per second squared. Negative again because g is pointing down. I need to find what is time t. So we use the third equation of motion that says delta y equals v initial along y-axis t plus half at squared. Now initial velocity along y-axis is 0. Because here, when the teddy bear was dropped, there was only x component of velocity, the velocity of the ring. So initial y velocity here is 0. And when I multiply 0 with t, the whole term over here will become 0. So now we can substitute the values. Delta y I will write as negative 14 equals v initial is 0. So when I multiply that with t, I get 0 plus half. A is acceleration due to gravity, which is g for me. I will write this as negative 9.81 t squared. Now we can rearrange the term here, or you can use shift solve to calculate t. When I rearrange, I get t squared equals, I will multiply with 2 on both sides. 2 times negative 14 divided by negative 9.81. And since I'm finding t, I will take square root on both sides. So we get t equals square root 2 times negative 14 over negative 9.81. And when I solve this, I get my time as 1.689 seconds. So this is the time it takes for the teddy bear to fall from a height edge to the ground. Once I have the value of t, now I can substitute that in my first equation. Let me write this as equation 1. I will substitute t in 1. So we get x equals vx times t. Velocity along x-axis is 1 times 1.689. So we get x equals 1.689 meter. So this is how far the teddy bear falls from the base of the Ferris wheel.